Okay, these are solutions for the chapter 2 study guide. So the domain is just your x values. So notice how I'm highlighting the x values. I put them in order. They happen to be in order, but that's not really anything to worry about. The range values are the y values. So they're the output values. So you can put those in ascending or descending order. I decided to put them in least to greatest, but again, not something you need to be concerned about. If you want to graph these, you can just kind of get an idea just to really hammer in that the domain is x and the range is y. I can plot those like here, and it's going to be a quadratic equation. Trying to draw the best curve I can. To really get an idea of what that looks like, you can put these into you can actually graph them in your calculator. So you can put that in your list 1 and list 2. So I'm putting those x values in one list, the y values in another list, and I'm going to stat plot. And you'll notice that my little sketch graph, even though I did it kind of really hastily, when I go to do it in the calculator, it looks almost identical to the way the calculator does it. So, and the scale, could look a little bit different if you want to, but just all you need to know is domain, x values, range is your y values. So here, same thing. Your domain is your x values, and I like to put them in those little box form is what that's called. I like to put them in little curly brackets. The range is y values. Okay, so you can plot what that looks like. This is going to be a linear function right here, modeled really well with the line. Plot all those points right there. And if again, I can put this in my TI-84. If I can sketch a little kind of like a little trend line, you don't have to sketch the line that goes through the points. All that matters is that you know basically how those things relate to each other. If I go to graph in the same window that I did before, it won't look right. You have to hit zoom stat to get a good window. All right, here, domain and range, we want to know about whether these things form a function. Notice how the x's cheat on the y's. There's one x that has two y's, so it's not a function. Whereas in the other one, each x goes to a separate y. So right here, if you want to graph it, see how there it fails the vertical line test. Whereas this one, if you graph it, it wouldn't fail the vertical line test because for each x, there's only one y. So this is going to be a function. Number 3 is not, number 4 is. All right, right here, we're evaluating functions at certain values. So all we're doing is plugging in the x value into the function. So we plug in 3 into the first one, and you just simplify, you get 1. You plug 1 into f, and then 2 into g, and then we simplify that whole thing. You can see me showing my work here. I do the order of operations. I do it one step at a time, but I'm just plugging those values in, simplifying, combining like terms, and here I get as my output value of 4. The last one's a little, the number 7 is a lot easier. Just plug in 0 into that. A lot of stuff just goes to 0. You get absolute value of -1, which is -1. At number 8, I plug 2 into the G, and I'm careful about how I subtract here. Notice how I'm going to use brackets when I subtract for the f of 0. I want to be careful here because you kind of have to distribute the negative. But instead of distributing a negative, I can just simplify first and just make sure that that is negative. I come out to 7 plus 5, which is 12. For number 9, again, I have subtraction. But I don't have to worry so much because those absolute value symbols kind of work like brackets or they work like parentheses. So it kind of makes me less likely to get a wrong answer there. If I simplify that, you should get -17. Here you double the function value of g at an x value of -4. Plug in -4 into g and just double that or multiply it by 2. So you get 22 as your final answer. All right, those are very simple. We're going to find the slope given a condition. So here we have an equation, y equals 5x minus 1, and we want it to be parallel, but we just take the slope. We don't even care about that point. When you're parallel to a line, you have the same slope. When you're perpendicular to a line, you have an opposite reciprocal slope. So I'm going to flip and reverse that slope. So instead of it being -2/1, it's +1/2. So flip and reverse it, opposite reciprocal. So your slope here is going to be 1/2. Now we're going to build on that. Instead of just finding the slopes, we're going to find the equations that have a slope and go through a certain point. So I don't care if you write it in standard form. I am going to write it in standard form, but I'm also going to put it in slope-intercept form, and I'm going to put it in point-slope form. So you can see me, this one's really easy because the y-intercept 0, 0 is given. I also put it in point-slope form in case you prefer. Here, I'm going to do slope-intercept form to solve this. Okay, I'm going to plug in the x and the y that are given, plug in the slope that's given, solve for the b. Once I solve for the b, you have to kind of do equivalent fractions. You can also do it in your calculator. and just do math inner if you want. And I put it in slope-intercept form here. But you can also put it in point-slope form. And if you want to put it in standard form, just know that you have the x part minus the y part equals the part, the whole number part. All right, here I'm going to put this in, again, I'm going to use slope-intercept form, and then after the fact, I'm going to put it in standard form. I plug in my slope is 4. I'm going to plug in my x and my y points. I get the b by itself, so I solve for the b. So in slope-intercept form, it's y equals 4, x equals 3. And there's point-slope form, and then there's standard form. Notice how the standard form, the 4 doesn't have a negative in front of it. So you might think it's -4 plus y equals +3, but you're supposed to have a positive x coefficient. The next one is really easy because you're given a y-intercept, so it's just you just write that out. Right? There's really no work to show. And I got my standard form equation. If you're wondering where I get that from, we don't want to have a fraction in front of the x. We want to have all whole numbers when you're doing standard form, so that's why I just double everything. All right, again, I don't require you to do point slope form here. You can do any form you want, but either way to find your equation, you have to find your slope. To find your slope, you do the y2 minus y1, and I'm going to use point slope form for these because the directions hint at trying it that way. So, and I already did it with slope-intercept form, but either way, you get something that's really easy to write in either form. Y equals -7/4 x is actually an accurate answer for it being point slope form because you don't need the 0. I'm going to do the slope formula again for the second one. Either way, your slope is -16. So I'm going to put it in point slope form once with one of those points. And then I'll put it in point slope form using the other points. If you subtract a negative, it's really adding. And I omitted using number 17, doing the other form of the point slope form, just because you could have used the -4 and the 7. But I didn't bother doing that. But it is an alternate option. So that's the equation that goes to those points. For this one, again, you have to find the slope of the line by subtracting the y's, then dividing by the difference of the x's. And so writing this in point slope form, you do y minus y1 equals m times x minus x1. And so I do the alternate version of that as well using the other point. And I also write this here in slope-intercept form in case you prefer that. If you prefer standard form, you can convert it as well. I omitted doing that here because the instructions. All right, again, find the slope, put it in point slope form. There's one version of point slope form. There's another version of point slope form. I also decided to go ahead and write it in slope-intercept form in case you prefer that. Here we're asked about direct variations. So remember, it's y equals kx. So we're trying to solve for the k. In other words, what you multiply by the x to get the y. So I solve for k by dividing the y by the x. So k is 8. Your function is y equals 8x, and we want to find the y when x is equal to -0.5. So I substitute -0.5 in place of x. So y is equal to 4 when x is -0.5. For number 22, y equals kx is your direct variation form. So 2/3 is equal to your k you get by dividing the y by the x. And then so y equals 2/3 x is your direct variation formula. I plug in -0.5, which is -1/2. I found it easier to use fractions here. So you get the y is equal to -1/3 when x is equal to -0.5 or -1/2. Here we want to write an equation in slope-intercept form, but they just give us the slope and the y-intercept. So you just write it directly. Now, this is just more practice. If you prefer writing stuff in standard form, here's how you write it in standard form. You get the x and the y all on one side, but you're supposed to have a positive x coefficient. So I changed the signs on everything, including the y there. So 3x minus y. Same thing here. You want to get the x and the y all on one side. And since the x coefficient is already positive, I don't need to do anything. More practice in case you have fractions. You want to get the x and the y all on one side, yeah, but at the same time, you don't want to have fractions, so I multiplied everything by 4 to cancel out that 4 denominator. And then when you move the x over to the other side, it makes it negative, but you don't want a negative coefficient on the x, so you change the sign on everything. For number 26, again, I have a fraction, and I'm going to do it the other direction first. First, I'm going to move the x over to the other side by adding 1/2 x. Then I'm going to multiply by 2 instead of, in case you thought it was cryptic, like it wasn't clear, why did I multiply by 4 in the other one? So that's it for part 1. What we're going to do is I'm going to post another video for the rest of the questions.